All right, welcome everybody. This is 1.3 Basic Exponent Properties. Okay, so an exponent is a quantity that shows the number of times a given number is being multiplied by itself. So for example, if we had x times x times x, well that's the same as x to the third. So that's telling us that we are going to multiply x by itself 3 times. All right, let's talk a little bit about vocab. An exponential term contains a coefficient, a base, and a power. Okay, and that power oftentimes is called, we also call an exponent. So if we look at this example, this would be our coefficient. We talked about coefficients before. Okay, when we talked about classifying polynomials. So coefficients are numbers in front of a variable. Remember that if we have something like x squared, we still have a coefficient that's out in the front, okay? And then we have our base, and this is our power, or our exponent. Okay, so we have coefficients, bases, and exponents. All right, so notice that to simplify, the two expressions have to have the same base. So if we had like x times y, obviously we can't combine those. We can't simplify them together. And then when we talk about coefficients, they multiply like normal. So let's do it a couple examples. Let's talk about the product of powers. So basically, what happens when we multiply like bases? What happens to their exponents? So one way we can do this is called expanding. So we know that x to the third, well, that's just x times x times x. And then we're multiplying it by x squared. Well, we know that that's x times x. So again, if we add all those up, how many x's are there? Well, that is x to the fifth. Okay, again, that's what exponents tell us, is how many times we multiply the base, how many times we multiply x, and we multiplied those x's 5 times. So x to the fifth. Okay, so what is the relationship? What happens when we multiply like bases? What do we do with that 3 and that 2? Well, we add those, okay? So let's see if that follows with our other ones, okay? Again, we multiply coefficients like normal, so that would be 6. And then here we have 4 y's, 1, 2, 3, 4. And then we have 8. 1, 2, 3, 4, 5, 6, 7, 8. So in total, how many y's do we have? Well, we have 12. So this would be 6y to the 12th. Again, we can just add those together. If we're multiplying the like bases, we can add them. So let's write that down. When we multiply like bases, okay, we add their exponents. Okay, so let's do this one a little quicker. We have like bases, which means we can add their exponents. So we'd get v to the 8th. And the y, we can't do anything with that because they don't have the same base. Okay, so keep that in mind. One way you can kind of write this, I don't know if this will help you, but if we have like x to the a, where a could be some number, and we multiply it by x to the b, where b could be another number, then what we do is we add a plus b. Okay, so like x to the 2 times x to the 3 is equal to x to the 2 plus 3, or x to the 5th. All right, so that is the product of powers. Let's talk about the quotient of powers. So let's again do the same sort of thing. Let's expand. Here we have x to the 5th. Well, that's just x times x times x times x. And on the bottom, in the denominator, we have x times x times x. Okay? Well, nice thing, if we have x divided by x, those are going to cancel out. and all we have left is just x times x, which is x squared. So what do you think you're supposed to do when we are dividing like bases? How could we come up with 2 using a 5 and a 3? Well, hopefully you figured it out that 5 minus 3 is 2, okay? So this is kind of the rule here. When we divide, and again, a fraction is division. That's basically, we're doing x to the 5th divided by x to the 3rd. And when we divide like bases, we subtract their exponents. Okay, top minus bottom. All right, so let's do this next one. Maybe you pause and see if you can do this one. So again, coefficients, you do exactly what they normally would do, so that would give us 3. And then we have y to the 10th divided by y squared. So again, we subtract those. We get 10 minus 2, which is 3y to the 8th. Again, thinking about it, this is like we have 2 y's here, and 2 of those are going to cancel up here, and that would give us 8. All right, so kind of doing the same thing, we could write this. This is like x to the a over x to the b. That's the same as x to the a minus b. Or if we did an example, which I did, well, we already did one over there, so that should be good. Okay, next, the 0 exponents. So what happens when we have 0 exponents? So to figure that out, let's kind of fill in this table. If you would pause and do these, and we'll see where we're at. So 2 to the 3rd, well, that's 2 times 2 times 2, so that should give us 8. 2 squared is 4, and then 2 to the 1, well, that's just 2. For 3's, we go like 27, and then 9, and then 3. Okay, so let's look at the first row. What is the pattern? What's going on every time? We had 8, and then 4, and then 2. So it looks like every time it's getting halved. Every time it's half. So if that's the case, then what would be our next path, our next spot here? Would go 8, and then 4, and then 2. Half of 2 would be 1. Okay? And then let's do the other one. So we have 27. Okay? If we divide that by 3, basically a third, we'd get to 9. And then a third of that would be 3. And then a third of that would be 1. So it looks like any time anything to the 0 is 1. So anything to the 0 is equal to 1. So y to the 0, well, that would just be 1. 2w, 2 times w, all to the 0 power would be 1. And what about 5r to the 0? Well, again, I guess we haven't really talked about this, but the exponent only applies to what's touching. So it's not affecting the 5. If it was like this, then the whole thing would be 1. But here, only r to the 0 is equal to 1. So that's like 5 times 1, which is just 5. So that one's a little tricky. Make sure the difference between these two. Okay, parentheses matter. All right. Negative exponents. So what happens if we have negative exponents? Well, if we were to continue this pattern, so all the 2's to the exponents, it's halved every time. So we did 8, then 4, then 2, then 1. So what would be half of 1? Well, that would be 1/2. And then we'd keep going, 1/4. And 1/4 is the same thing as doing 2 to the 2. Okay, and this would be the same as 2 to the 3, 1 over 2 to the 3. So it looks like whenever we have negative exponents, And you could plug this into your calculator and to verify that's what you'd get. Okay? So any negative exponents, and that's one thing we should mention, is that our answer should never have negative exponents. So never negative exponents in answer. Okay? So to get rid of that, we would do exactly what we wrote down here, okay? Is we basically moved it to the bottom and changed the sign of the exponent. We did that for all of those. So this would be like 2 to the positive 1. We move it to the bottom and we change its sign. All right, so here we could rewrite this as 1 over t to the positive 7. Those are the same. If you're like, where'd that 1 come from? Well, remember, we said that coefficients, or every variable has a coefficient, okay? And that 1 isn't being affected by that negative 7. So that 1 will stay. The t to the negative 7 goes to the bottom, and we change its sign. Just the exponent, okay? So here's another example. Again, this exponent only applies to what's touching. There's not a parenthesis around that 5r. It's just the r that's being affected. So we would need to move that to the top and change its sign. So we'd have r to the positive 1 over 5. If you wanted to have that 1 out there again in the front, you could. But typically we would simplify that. We'd actually even simplify it to just r over 5. Okay? Because r to the 1 is just r. So that's exponent rules, with negative exponents. Again, if we had something like x to the negative a, where a could be a number, then we would need to write it as 1 over x to the positive a. Or if we had 1 over x to the negative a, then we can move it to the top and change its the exponent sign. Right? Now we have power to a power. So what happens when we have a power to a power, like an exponent on top of an exponent? Well, let's figure this out. So again, we tell us the exponents tells us how many times to multiply the base. So this would be our base. And we can write x squared 3 times. And if we wanted to, we could even expand each of these x squared. So that would give us x times x times x times x times x times x. So how many x's do we have? Well, we have 6. So that would be x to the 6th. So what's the relationship? What do we need to do to 2 and 3 to give us 6? Well, we just multiply them. Okay? So let's write that down. When we have a power, or when we have like bases and we have a power to a power, then we multiply the exponents. Okay. All right. And for some reason, people really struggle when we our first and our last. So when we have a product of powers, when we multiply like bases, we add, and when we have a power to a power, we multiply. All right. So here's an example. So again, everything here is being squared. The 2 is being squared. The x to the 4th is being squared. So if you want to expand those, that's great. You could do 2x to the 4th times 2x to the 4th. We'd multiply 2 times 2 is 4. And again, we learned that if we have like bases and we're multiplying them, then we add. So that would give us x to the 8th. Okay? If you prefer, we can use kind of like our rule here. We just need to realize that this has an exponent of 1. So we multiply that exponent and that exponent. So this would be like 2 to the 2, and x to the 8th. And we could simplify that to give us 4x to the 8th. Okay? All right. One thing we need to talk about real quick, let's go back to this. Okay, so there's kind of a difference here. In this example, this was 1.2. When we had something squared, we wrote it twice. And you have to do that whenever you have some sort of addition or subtraction, okay, within that parenthesis. So again, here we cannot just say we can't write it as 2 squared x squared minus 3 squared. Okay, that will not work for you. So make sure there's kind of that difference. If you're worried about that, then maybe just expand this every time. Rewrite these twice and multiply them when needed. Okay, so here's another one. Again, this would be like 2 to the 4th, x to the 4th times 3 to the 4th, y to the 4th. And then we could use our calculators to figure out what that is. And again, these x and this y, those can't be combined. So let's figure that out real quick. So 2 to the 4th gives you 16, x to the 4th, and then 3 to the 4th, would be 81, y to the 4th. And then we can multiply those together. So we end up getting this. Okay, so there's some examples. Most of what you'll have on your homework and your tests will be covered by that. So again, I wanted to maybe finish this. So if we have like x to the negative 1, we could do this as 1 over x to the positive 1, or 1 over x to the positive 2, or 1 over x to the positive 3, okay? And these, if you wanted to put them as a negative, you could move those to the bottom. Okay. All right. So the rest of this is just examples. I will continue on that with this video. It will make it probably a little long, but you're welcome to do as many as you'd like, practice as much as you'd like, okay? All right, so here we go. We're multiplying like bases. Their exponents here would be like a 1. Again, coefficients, we multiply like normal, so 2 times 2 is 4. And we're multiplying like bases, which means we're going to add their exponents. So that'd be n squared. Okay, why don't you give this one a try? So 2 times 5 is 10. Here we're going to add their exponents, so that'd be x to the 5th. Here's another one. We have our coefficient. If you wanted to, you could put a coefficient for this one. That'd be 2 times 1 is 2. And here we will add their exponents, so that'd just be x to the 3. Okay, another way you could do that is you could just say that it's 1, since we know that anything to the 0 is 1. All right, so that is like multiplication. Here's another multiplication. 3 times 2 is 6. And then again, we're going to add these. So what is x to the 4 plus a negative 3? Well, that would give us 6x to the 1, or just x. Okay. So again, we're still multiplying like bases, so we can add something that's negative. Here's another one. 6 times 3 is 18. And then we'll do x to the negative 2 plus 1. Again, this is an exponent of 1. So it looks like that would give us 18x to the negative 1. But wait, we don't want to have negative exponents, so we would need to bring that to the bottom. Again, this negative exponent only applies to this x. So we would need to leave the 18 and then bring the x to the bottom. Okay? All right, now we have a power to a power. So again, what do? We multiply their exponents. So here we have 4 to the 2 and x to the 0 times 2. Well, that's just 0. And x to the 0 is just 1. So we should have 16 times 1, which is just 16. All right. Here's another one. We have a power to a power, so we multiply. That would give us x to the positive 6. Because a negative times a negative is a positive. Okay, we have 5 squared, and then x to the 6th. So 25x to the 6th. Anything to the 0 is 1. Okay, now we're doing division. What happens when we have like bases and we're dividing? Well, then we subtract their exponents. Okay, so this would be x to the 4 minus 2. And this coefficient that was down here, that will stay. Okay, so that gives us x squared over 2. Another way you could kind of think about it is we have 2 x's on the bottom. We'll just need to take off 2 on the top. I guess it would be x squared. Okay. Or, again, if you prefer, you can expand things out, like x times x times x over 2 times x times x. Those will cancel, and we just get x squared over 2. All right, here's another one. Simplify. 4 divided by 2 is 2. And then we have y squared minus negative 1. Again, we have like bases. They're being divided by, so we'll subtract their exponents. So we end up getting 2y to the 3rd. Okay? There's lots of different ways to do this. Like here, you could have just brought this to the top. And then you could have added those exponents since they're being multiplied at that point. So there's lots of different ways you could go about doing these problems. Here's another. Okay, maybe here we'll just expand. Let's see what happens if we just expand. So we have that cancels. We end up getting 3 over 2x. If you didn't expand and want to use your subtraction, like if they're divided, we subtract, then we would do 3x to the 2 minus 3 over 2. Okay, and then that would end up giving us 3x to the negative 1 over 2, which means we'd need to bring that x to the negative 1 to the bottom, just like that. And they're the same. All right, here's a couple more and we'll be done. Okay, it looks like we're using the, when we divide, so the quotient, the power of, or the gosh, what's it called? The quotient of powers, okay, when we're dividing exponents. So here we would do 2y to the negative 2, negative 3 minus what's on the bottom. And that would give us 2y to the negative 6 over 4. Okay. Looks like we could simplify this. This is 1/2 instead of 2/4. And we have this negative exponent we need to move to the bottom. So we'll do 1 over 2y to the 6th. Okay. Again, another way to do is if you want to get rid of that negative first off, move it to the bottom and change its sign. And then we can just add those exponents. Okay. All right. When we have two variables, it's okay. We just do them one at a time. So coefficients, bam, that's 8. We look at our x's. They are being multiplied. So we'll add their exponents. So x to the 4th. 1 plus 3 is 4. And then we'll do our y's. So this is y, this will be y2 plus a negative 3. So that should give us 8x to the 4th, y to the negative 1. But wait, we don't want negative exponents. So we will just move it to the bottom, and we're good to go. Okay, maybe I should have had that as a separate step. All right. Last but not least, maybe here we'll expand. So 2x, x, y, y, y over 4x, y, 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 y. Okay, we can cancel out 3 of the y's and 1 of the x's. And this can be simplified to 1/2. So what's left is we have 1x on the top, or just x. And on the bottom, looks like we have 2y. So we have this 2 and this y that's left. All right. Well, either way, you can do the rule or you can expand and cancel. The one thing that you can't do is you can't expand something with a negative exponent. So you would need to bring that down first, and then you can expand. All right, well, if you have any questions, please let me know, and I'd love to help you out. See ya.